say, I haven't seen David Devorkin, but I'm glad he's here. So the last speaker to take us up to TV was David, who is a historian at the Smithsonian Institute.
Does it work with you? Keyboard cannot be identified.
Just hit continue, it'll work.
Here, I'll just use that sheet.
Okay, just hit continue, it'll work. Just continue, just no this. You guys are troublemakers. Yeah, all right, try it.
Do I press on
Push the right button to go right.
Okay. Yeah, that's fine. Thanks. Yeah, many thanks for that. That's helpful. This is a title that was a modification of another title, and then I went back to my original. I am prepared to speak of Russell as a loyal Lowellian, if anyone is curious about that. It's a rather convoluted story, but today I wanted to limit myself just to the theme of the conference. Well, who is Russell? We've heard about him here several times, and very briefly, of course, you always indicate, you know, the prominence of somebody by how many times he's photographed and how many of his photographs survive. And in Russell's case, quite a few of them do, and I added this one down here that personifies his association with the Lowell Observatory. That is Putnam, of course, in 1927. Now, Russell's influence, of course, has to be understood at two levels. One is his influence within the profession, and he came to be known repeatedly as the Dean of American Astronomers because he would advise and consent at many observatories, and his word was typically law. That is a sort of phenomenon that does not exist anymore in the discipline today, and probably for good reason. But he was also known popularly because for some 43 years he had a monthly column in the Scientific American that became a referendum on the state of astronomy. And if you were mentioned in that column at any point, your career was enhanced considerably, as the astronomer Jesse Greenstein wrote to Russell delightedly in the late 1930s when Russell noticed some of his work. Well, my purpose today is not so much to look at all of the many, oh, come on, George, stop that, okay. Many different ways that Russell acted as intellectual patron for the Lowell Observatory, but to rationalize why he did, and to point to one particular place where, even though his patronage was very lukewarm, it wasn't because of the good work done at the Lowell Observatory by V.M. Slipher. It was because of deeper reservations that Russell himself harbored about the idea of an expanding universe. And I think that could be the most valuable thing that I would present here today, and that is Russell's reticence, deep reticence, in spite of all of the evidence that had been accumulating, both theoretical and observational, through the 1930s. I also want to place Russell as a theorist, and that will help you understand why Russell acted as patron to observatories like the Lowell Observatory. Russell did produce his own data from time to time. In fact, the Russell diagram was based upon parallax data that he took at Cambridge as a postdoc after his postdoc years, and was very much the last observing that he did of any kind of substantial form. After that, he pretty much depended upon the observations of others. As a theorist, he was guided by observation, and then he felt that theory should also guide observation. But the type of observation that Russell promoted was focused, problem-oriented observation, and I'll get to that in a few minutes, but keep that in mind in terms of how we go through this today. Also influencing my talk today is a quote from the American Institute of Physics website on cosmology, which is one of the finest I think I've found to date. It was done by the late Norris Hetherington and Patrick McCrae, and Robert and a few others, including myself, advised on the project, and it really is quite a good popular introduction to cosmology that's accessible very broadly. And in there it says it's an open, historical, and philosophical question in what sense Hubble's correlation, and that's the key for me, of data was a discovery, and exactly how the claim that the universe is expanding grew in scientists' minds. Now, this issue of correlation is very important to understand early 20th century astronomy, especially in the United States. I like to call it the Great Correlation Era in astronomy, where things like the HR diagram, spectroscopic parallaxes, even the mass luminosity relationship began as observational correlations. And they began as these correlations without understanding the theoretical underpinnings that brought them into existence in nature. And that was a very, very definite crisis in astronomy just about around World War I, when people like Adams, Walter Sidney Adams, who I would say temperamentally was probably similar to Slipher in many ways, began worrying about what did all of these correlations mean. I mean, they really did not have more than an empirical understanding of what was going on out there. And the Hubble relation is another one of those correlations. And so we're dealing with a community that had, by then at least, some confidence that they would ultimately figure out what these correlations meant, but usually they also knew that it wasn't going to be a quick procedure. Well, at the very meeting that Russell presented his Russell diagram, as you may want to call it, I don't go by hairdos only. Besides, Russell did change his hairdo on many occasions. There was another fellow there, Philip Fox, and Fox was the secretary of the society, and he read a paper by V.M. Slipher. And this was the very first outing, you might say, of Slipher's observations of the high velocities of the white nebulae, as they were called, the spirals. And it was done in absentia because Slipher was reluctant to travel, keeping him away from the telescope. This is not an anecdotal thing. He said that constantly to Russell. Whenever Russell and others proposed him for national prizes, he was very reluctant to actually show up and accept them because that took him away from the telescope, and those were his words. Well, sorry, I'm just getting egotistical there. Fox, a few years later, related to Slipher how his very first paper was accepted, and said it was greeted with some expression of incredulity, especially on the part of Professor Russell, to which I made a heated rejoinder. And Owen, I'd love to get into that time machine also and get back there and try to figure out what the rejoinder was. There is no published reference to it, and Fox did not, at least I haven't found it in correspondence, correspond with Slipher at that time. So, Fox was recalling this just after Slipher had won the Lalande Prize for his work on nebulae. Well, anyway, moving on, my question now is, how did Russell come around? Because his first reactions were just as surprising as Campbell's, and I would say it wouldn't be surprising to have a reaction like that. Well, Robert Smith and others have well covered how Slipher experimented with his spectrograph, practicing essentially a cut and try iterative scheme until he produced usable spectra. Also well covered is what attracted Slipher to the nebula. If not his boss's preoccupation with Mars, as Bill Putnam and Robert Smith have said, Mars is an abode of life far older than the Earth. They were trying to get at actual clumping rates for objects in solar systems of different ages. Certainly it was because of his fascination with the spectroscopic technique itself as a tour de force and its application to motions in the line of sight. Rotations, translations, you name it. And we've already heard about the use of radial velocities for the Mars filter. Well, Russell was familiar with Slipher's work mainly on Mars up to this time, and admittedly, it did not have the best reputation. But there is no indication even at that time that there was anything more than sympathy for Slipher working at an observatory where, as various people have said in correspondence, seeing the canals was a condition of employment. So Russell was sympathetic with Slipher's situation and rapidly became very impressed with his ability and his persistence at producing good radial velocities. Of what phenomena, that would be another issue. One of the first observations that he was impressed by was in spectroscopic binary stars, where Slipher found lines that didn't partake in the orbital motion. And of course, that was the observation of the interstellar medium, which was a very controversial observation at that time, again, because of Kapteyn, who rejected the idea of an interstellar absorbing medium. Well, in April 1913, Russell discussed the problems of nebular spectroscopy in his Scientific American column, and I'll be going through the Scientific American column here in the talk. He looked especially at how Slipher obtained the spectrum of diffuse illumination engulfing the Pleiades. And he was very, very impressed, describing how difficult the process was. And this became Slipher's reputation. And this is the way that Russell built up his reputation to an international audience. Russell announced that Slipher was up to the task. And he determined that the spectrum was due to the reflection of light by a veil of thin dust, not a trivial observation. Well, looking back also on highlights of the year, which Russell would present at the end of every year, he also gave this observation his highest accolades, right up there with Hale's continued search for the general magnetic field of the sun. But when you're talking about patronage, you have to understand, Hale had not found the general magnetic field of the sun, and yet Russell thought it was incumbent upon him to congratulate Hale on continuing to look for it as one of the major events of the year. And the other one he mentioned was Slipher, a little insight into the power structure. Within a few months after that, he encouraged his Scientific American editors, however, to give Slipher a platform and to state his case for nebular rotation as well as the recession, if you thought of it as a recession, that's my word, sorry, in June 1914, discussing its importance for, quote, stellar and nebular evolution. So this, of course, puts Russell squarely in the solar system realm, looking at these things, trying to understand their dynamics. Russell also continually encouraged coverage of Lowellian studies of Mars with the editors, primarily because he knew it was an extremely popular subject. Slipher's continued detection of the high radial velocities was also noted prominently in the September 1914 issue. By April 1915, Russell felt that Slipher had collected enough evidence for the phenomenon to devote over 2 columns of his own column, which was that sort of referendum on the state of the discipline, and started it out with this. Among the most difficult of the yet unsolved problems of astronomy is that of the distances, dimensions, and nature of the nebulae. By now, he was getting impressed enough so that when he was careful about his wording, he didn't couch it completely in a nebular hypothesis context. But that's, in my opinion, still where his heart resided. Photography, Russell added, had recently shown that the spectra of the spiral forms of these objects resembled stellar spectra, wholly unlike the spectra of the brighter green nebulae. This meant that they were either single stars cloaked in gas and dust, or assemblages of stars at vast distances. Russell then introduced Slipher's accumulating observations of spiral RVs, now confirmed by others, Russell claimed, and in April 1915 there really weren't others, that showed them to be in the range of many hundreds of miles per second, some 25 times the average of the radial velocities for the stars. If there was such great motion in the line of sight, then Russell calculated, one of the neat things about his columns is that he would actually develop his thinking for his readers to bring them along. And the idea is that if you have a set of objects, stars, nebulae, whatever, with a certain radial velocity, you would expect that you are looking at some of them preferentially that are really, moving directly in your line of sight, some maybe obliquely, some maybe even transverse, and that there were statistical ways for figuring out, well, what would the average space velocity be of something that, as a class, has this average radial velocity. And that's the sort of exercise that Russell took his readers through. And he identified two classes, of course. One would be the white nebulae, and the others would be the planetaries. And the planetaries, Russell calculated, must be moving at least 15 astronomical units a year, whereas the white spirals were traveling an astounding 120 astronomical units per year by his calculations at that time. Now, given this estimate and the vanishing small proper motions that were available for a few of those, and apparently I heard in an earlier talk somebody talking about the parallax of some of these nebulae. Yes, there were a few, but very few people believed them. That was an extremely iffy kind of calculation or observation. But given this and the vanishingly small proper motions that had been found, which were just really within the error of the instruments, they had to be at least 8,000 to 10,000 light years away, Russell calculated. But more likely, they could be in the tens to 20,000s of light years. And so he concluded the dimensions, the dimensions which the nebulae must have to appear as big as they do at such distances are astounding. So he's coming around slowly after a few years. He then compared Hertzsprung's estimates of the distance of the small Magellanic Cloud of some 30,000 light years and realized that if what Hertzsprung was calculating based upon the Harvard observations was accurate, that the distances to these unresolved nebulae farther than the Magellanic Clouds must be even greater. And so he ended saying it may well be that we are on the brink of an expansion, I love the use of that word, of our conception of the extent of the universe, almost comparable to that which resulted from the first measurements of the distances of the nearest stars. Now that's a curious statement because the first parallaxes, of course, gave the distances of stars, but it wasn't a revolutionary observation. There was some, pretty good evidence the stars were not local. And so I'm not sure what Russell meant by this, but as we know, Russell wasn't the best historian. Okay, well, by late 1917, again, as Robert has pointed out and others have related so well, Slipher's continuing efforts were now bolstered by Francis Pease's work at the 60-inch and had won most people over. You had to deal with these radial velocities. They were real. They gave strong evidence that they were not solar systems in formation. They were not stars. To Hertzsprung and others, these speeds meant the spirals could not be bound to the Milky Way. And by 1917, Slipher agreed with them. Sorry? Oh, boy. Okay. Well, Russell was clearly among Slipher's advocates, but he was less willing to accept the extragalactic nature of the spirals. On many occasions, he would write notes to himself after attending Slipher's lectures at AAS meetings, and he would make inferences that made him think of interpretations related to planetary motion or the nebular hypothesis. Once Russell mused that Andromeda's rotational motion was reminiscent of the system of Saturn. Now, I want to move on to Russell's influential Some Problems in Sidereal Astronomy, which was a referendum on astronomy that was put forth by the National Academy and the National Research Council. It started before or during World War I, but it wasn't published until after World War I, so there's some continuing question as to exactly when various things were in it. But in that particular report, Russell started out, and this was a series of essays by astronomers that he introduced. He restated what he believed to be the main disciplinary characteristic of astronomy, the way it should go. The main object of astronomy is of all science is not the collection of facts, but the development on the basis of collected facts of satisfactory theories regarding the nature, mutual relations, and probable history and evolution of the objects of study. He's basically saying here that undirected, open-ended, cartographic observations of the heavens, what he had depended upon and everybody else had, of course, from the Harvard projects, and then now at the Lick project, wasn't the way to go. It really was more focused, problem-oriented kinds of observational studies that were based upon questions. And that is another reason why he supported the Lowell Observatory, and especially Slipher over these years. He wrote in that Some Problems that the spirals may be or seem to be the most extraordinary objects in the heavens. They're enormous radial velocities detected by Slipher, and almost equally rapid internal motions within them. And now, by then, that is of course Van Manen. Put them in a class by themselves. He is still hoping that there is evidence, of course, that there may be a solar system type formation, but meanwhile, at least he encouraged their study as a class, to look at their kinematics. He continued to compliment Slipher because Slipher, as he continued studying the nebulae, was coming up with more and more very interesting observations. In the letter to Adams, Russell hailed Slipher's work on the luminescence of nebulae, saying it was due to some influence emanating from the hot stars within it. Another piece of evidence that the nebular lines are produced by known atoms, under unknown conditions of excitation. This, pardon?
It's right.
Yes, it is right, absolutely right. This is 1920, and of course it wasn't right, didn't discover it until another 8-9 years by Howard Bowen and people like that. But it was Slipher's observations that gave Russell these ideas. This is the key, I think, to their relationship. Shapley, of course, was none too positive. He wrote also quite a bit with Slipher, and trying to remind Slipher that the only thing that was really solid were his own calibrations of the globular clusters and the size of his Milky Way. And this is one of his little snippets to Slipher in 1918. Russell in the 1920s also started giving more and more lectures on the cultural meaning of all of this new astronomy. And he continually started revealing more and more of his inner thoughts, especially in a series of Toronto lectures in 1924. The very last lecture was on the nature of the extragalactic nebulae. And he had to say, really, in terms of the matter of the universe and of the nature of these nebulae, how they got there, we do not know anything at all. We don't ask that question. It is no business of science to explain how matter got into space, only supposing that there was matter in space, what would be the history of it. This lies at the base of his difficulty with the nature of the expanding universe. He continued, of course, to promote Slipher's work, as did Campbell. I was amazed to find this kind of statement from a person like Campbell in 1923, who was plying the Carnegie Corporation for more money to literally continue Slipher's work in the southern hemisphere. Because the big problem then was the kinematic shape. They had to get the southern galaxies to be able to determine what the drift was relative to the galaxy. So there's no question in my mind, looking at all of this, that Slipher's work was never in question. It was a question of what it meant. Here is a letter from Russell to an author, Margaret Deland, very well-known author at the time, and she was asking about God. And what can science say about God? Russell said, I suppose it is because I'm a physicist that I find it hard to think of God as becoming. This is the idea of an evolutionary universe. He really had problems with that. Of course, none of us hope for a full understanding of the power behind the universe, but those of us who study the universe, at least from the material side, do not find evidence of progress at the heart of things. And this issue, I have to, maybe somebody can help me here, is to the extent to which, and this is what I'm interested in, is the extent to which a expanding universe was a progressively changing universe. He did not want that. So these are just continued quotes that I've extracted from Russell's correspondence. Russell was in residence in Pasadena when he first learned in January. This is about 4 days before Hubble actually submitted his paper. But he has definite evidence at last that radial velocities of non-galactic nebulae increase with distance. The key for me is at last. This verifies, of course, what we have been developing here is that it was in the air throughout the 20s, and it was just a question of somebody coming up with the right or the best data, the most selected data. So it is no surprise that Hubble came up with this. But the explanation may involve a de Sitter universe or some new mathematical invention. It is too early to say, and that was not Russell's concern. He simply left this one brief statement to Lamplin, who was, of course, a Lowell staffer, and moved on to what was important in his mind. By then, it was the composition of the solar atmosphere. So I have a lot more quotes, and I know my time is up here.
3 minutes ago, actually.
Okay. But I think the most interesting part of revealing of where Russell's feelings came was in a series of lectures called The Solar System and Its Origin in 1934. Oh, darn. Let's see. The way he reconciled the expanding universe was to argue that it helped him produce more solar systems in the universe. How is that? Taking the implication of the expanding universe, that meant in past time, the universe must have been more concentrated. And also, given his theory of stellar evolution, stars were younger and they were larger because stars began as red giants. So bigger stars, a more compact universe, you get more collisions. And so deprived of the nebular hypothesis by the Chamberlain-Moulton, which of course his student Spitzer helped to demolish, Russell at least could think that the universe was still populated. That was the driving, you might say, paradigmatic thought in his mind that guided most of his thinking throughout his career. So sorry if I went over, but that's it. Thanks.
Okay, sorry to push you, but you have, as a result, got a couple of minutes for some questions.
In light of Robert's talk this morning, it was interesting to see Russell advocating for Slipher so strongly early on. So do you have any sense of how it was that Russell came to decide that Slipher was credible and producing good results? Did he come see him observe, talk to him? Do you have a sense of how the connection was?
Yeah, I'm not sure when they first met, but it's very clear to me every time that Slipher came up with a new observation, whether it be the interstellar medium, the reflection nebulae, one thing after another, Russell was always very excited about it. I think, again, to build on something Robert had said, Russell, as Dean of American Astronomers, tried to influence observatories to be more problem-oriented. And it's pretty clear that Slipher was always very problem-oriented, and that was just the type of observer Russell wanted, especially in his pocket.
So you think it could have been more of a strategic move on Russell's part?
Of course.
Actually,
oh, absolutely, absolutely. He did the same thing at Mount Wilson. He did far less at Lick because, as Russell would say, the Lick state of mind resisted it. He shifted from Pickering early in his career to Hale because this was very much Hale's view of how astronomy should progress, and that is problem-oriented.
Yeah, that touches on exactly the question I had. So in Robert's talk, he talked about how Campbell was very, very suspicious in those early years.
Well, so was Russell.
Yeah, but I mean, Campbell, it seemed like even earlier so.
No,
and, you know,
it's about the same time.
But Campbell seemed like he was very venomous, but he also changed his mind, and it's impressive that he did so. And
well, that's a good point because Campbell's getting a bad rap.
He is. He's got a
yes.
bad rap here today.
Yes. we'll discuss that. But,
so
no,
why do you think he changed his mind? What made him do it?
The same reason Russell did. The numbers were consistent.
They were.
I mean, to give you more, the most interesting detail, I can't remember who it was who criticized Slipher's early observations based upon the scatter, the great scatter in some of the numbers. And someone pointed out, I think it was Russell, said, well, that scatter proportionally to the size of the radial velocity is the same as the scatter for radial velocities generally. So what are you complaining about? I mean, look, they tried the same thing with Hubble. When Hubble's first stuff came out in '29, Slipher was skeptical. Duncan at Mount Wilson was skeptical, and Adams was very skeptical. Why? Because when they looked at the Coma cluster, they had two velocities of the galaxies in the same cluster separated by over 3,000 kilometers per second. They were skeptical. But Slipher's stuff had a smaller scatter than others. They were looking at it. Oh, I should point out, in all of Russell's later discussions of Slipher's work, and especially, he's very clinical. He gets very, very clinical later in life because he can't deny all of this stuff anymore, but he has to deal with it, so he goes clinical.
And do you think that these, like the Dean and these kind of big shots that came on Slipher's side in the long run are the ones that got him the Bruce Medal and all this kind of stuff? They must have been the movers.
Early on, absolutely.
Yeah.
The Henry Draper and all of that. There was a falling out later in the 30s, mainly over nativism and the problem of foreign refugees. And that's another long story.
Can I just add,
Yeah, sure.
I don't see any inconsistency between the positions of Russell and Campbell.
No.
In
Right.
1913, David pointed out that letter that Fox writes saying Russell was very animated.
Exactly.
Right?
Well, I thought it was dated 1920. It was 1930.
No. Oh, I'm sorry. Yeah, that could be confusing.
Yeah, that was confusing.
Fox was recalling this in 1920, congratulating Slipher on the Lalande
That's why my
Prize.
dates were
Remember.
confused. Okay.
I'm sorry.
So in 1930, when they've only got one result, which is
Exactly.
a nebula,
Yeah.
both Russell and Campbell are very skeptical.
Yeah.
But once you get, say, to 1914, where
Right.
Slipher is able to present 15, plus a few other observatories had confirmed Slipher's results, it's a different business.
Yeah. I'd be skeptical too, for heaven's sake.
Good. Well, if we thank David and all our speakers now, then we have 10 minutes, no, 20 minutes.